Lifeblood is a task management software package. It lets you process arbitrary tasks with logic defined by nodes and driven by task attributes. This tutorial is of one very particular application. It doesn't go into details or logic of Lifeblood, it shows you how to use one of predefined setups. It may be better to see some practical examples before diving into theory. Here we will create a simple setup for caching geometry, and then one for wedging simulations. As a result of this tutorial, you will have a workflow to submit simulations or geometry caching to Lifeblood. First, let's take a look at Houdini side. Lifeblood comes with a Houdini node. This may seem like a small node, but actually it covers most of generic use cases for Lifeblood. It can create tasks with arbitrary attributes on arbitrary Lifeblood nodes. For a created task to make sense, we need to know what attributes drive our setup in Lifeblood. In this case, thankfully, there is a preset already. This preset turns Lifeblood submitter into something with more familiar interface. Here you can select the required node to cache, frame range, resource requirements, and well, other stuff. Note that to submit a file cache node like here, we will have to specify the inner rope geometry node in the submitter. So let's do that. And basically we're done here. Let's now take a look at Lifeblood side. Here, similar to Houdini, we can use tab to invoke node creation menu. Here we are looking for a caching preset. Here it is. Now, if you already saw the mantra tutorial, you can notice that this preset is much simpler looking than the mantra one, and yes, it is. This node will split frame range into chunks if we are not caching simulation, and if we are caching simulation, this will just do nothing, create one chunk. This node actually renders arbitrary rope node in Houdini. In this case it will be our rope geometry node, and this one just collects all the frame chunks back into one task, and that's it. We don't need to adjust anything in this preset, so let's just submit the task. Since we just created this node, it doesn't yet know the address of the scheduler, so the easiest way to set it up, just click the button to listen for the broadcasts. And now we're ready. And you see there is not much tasks created, just one that does all the simulation. Now let's take a look at the cache. And indeed, the simulation was cached. Now let's wedge this simulation. Let's do the most trivial wedge. We will just wedge this fracture seed. First, let's go to Lifeblood and create the wedging preset. You may notice that in this preset the three middle nodes are actually the same from the simple caching setup. Yeah, because basically does the same, just with wedging. The wedge nodes create splits according to required wedge attribute, and the gather node gathers them together. Note that attribute wedging and frame range splitting here are done with the same concept of task splitting and gathering. It's one of the core concepts of Lifeblood. So let's go now back to Houdini and create the submitter to submit these wedges. Now let's create a new Lifeblood submitter and use a wedging preset on this one. Most of the parameters are the same as on the one for caching, except here we have attribute to wedge that can be set. For each wedge task, this wedge attribute will be set to some number from 0 to 9, total count of 10 in this case. We want the total of 9 wedges, so with numbers from, I don't know, 100 to 108. Though for seed the actual numbers don't really mean much as long as they're different. Let's now rename this attribute to something like seed for fracture, why not? This attribute will be available as context variable during the caching process. So we can use it in seeding as simple as this. And why not? We can also add it to secondaries. Now we need to add the wedge attribute to the cache path to have them in different distinct folders. So let's call it like this. And we also forgot to specify the ROP node. Let's just copy it from here. Now we're definitely ready to go. And the wedges are done. Now to preview them, we can use context options that allow us to set values to context variables just like top nodes can, but manually. And now we can preview the results of each individual wedge using this context parameter variable attribute. Now let's make one more step in this setup. Let's make a mosaic preview for all of our wedges. To do that, we will have to set up something for rendering, add the camera, add the ground, add a light source maybe, and set up mantra node. Now let's take a look at Lifeblood side. Here we will create a default mantra preset. Now you might be familiar with this one from the mantra tutorial. And we will connect it right after the caching of a single wedge is done. After caching of each of the single wedges will be done. And here, resources in the preset are driven by attributes, but for this example we will just delete it and use constant values. Now, when we collect wedges here, each of the wedges will have a images attribute containing list of all rendered files. We will combine them into a list of lists of images, because this is the way FFmpeg node ingests input for mosaic generation. We'll use the append mode, so all lists are appended into a new list, not extended into one single list. And we will add the FFmpeg node. That will look for the images And that is good enough. For simplicity, we will set our render to be done in PNGs, just not to deal with linear color space. And we will need to specify the wedge number somewhere in the path here. Now, one thing we need for the render preset to work is to specify the hip driver attribute that will be rendered, and this is our mantra node. So since this Lifeblood preset doesn't have it, we can just add it manually here. It will be a string, just path to our node. The name is... Here we are already using hip driver attribute to specify the rope node to cache, so we will have to use a different name and then rename it somewhere in Lifeblood. Thankfully, renaming attribute is easy. Here we will set the attribute named hip driver, type string. We will set it to the value of hip driver mantra attribute. One thing that we forgot to set is that we need to set the wedge attribute as context attribute during the IFD generation as well. And now, just to make it faster, let's simplify this rendering parameters and let's override camera resolution to be half. And now we should be ready. Even 50 frames for 9 wedges would total up to 450 frames to render, so it will take some time even with fast render settings. Now let's take a look at the result. And here is the result. All the wedges rendered in poor quality. And that concludes our tutorial for today.